All right, in today's short module, we want to consider how to derive v squared over r as the acceleration in a circular orbit. Many times this term v squared over r just comes out of nowhere, and we're going to need v squared over r in the next module to directly show how Newton's law of gravity exactly predicts Kepler's third law. This derivation is done relatively simple, and we're going to do it with just geometric principles. So to begin with, we draw a picture of the system. That's always a good place to start. And so here we have an origin, and something's in orbit about the origin. That's located here. Its inertial velocity will have it move from A to C at some distance equal to v times t, where the velocity is a tangential velocity. During that amount of time t, the object has also free-falled toward the origin at a rate given by 1/2 at squared. So those are the words associated with what I just said. How surprising. Now, the motion from C to D is the motion that we want to describe in some way so as we can derive the relation between the acceleration and the velocity and the radius. So let's call this distance from C to D x. So now referring to this diagram, the three relevant distances are O to A, it's the radius of the circle, which is r, A to C, which is just the distance given by the tangential velocity vt, and the distance from O to C, which is given by the radius here plus this incremental amount x. So we can simplify that because we want to apply a squared plus b squared equals c squared by just mapping those things onto distances a, b, and c. So you get a squared plus b squared equals c squared, and with respect to the definitions here, that's a squared plus b squared equals c squared, where that distance is r plus x. Now you can do a little bit of algebra to isolate some terms and end up with this awkward looking equation, which really can't be solved easily. And that leads to a typical situation in most physics problems. We need to make an assumption to continue further. Now at this point, you can ask for a discussion about what the assumption might be, etc., etc. I know from experience that in a real class these days, no one's going to say anything. So the assumption that we need to make is that r, that distance, has to be very much greater than x, so that r plus x just equals r. The way you make that assumption is you just talk about small units of time. If the time interval is very short, then that is solved. X is much, much less than r. So then you can isolate the v squared over r term in this to achieve that, where 2x over t squared is identical to that, which is the acceleration. Hence, v squared over r equals the acceleration.